All right. Okay, what you're seeing here, it's actually the sort of what a 3D printer looks like. Of course, it comes in a lot of different forms, but I'm just showing the low-end, low-cost 3D printers. So goes by term FFF or FDM, fused fabrication, filament fabrication, and then fused deposition modeling. So the 3D printer on the left is Cartesian XYZ, and the one on the right is a Delta 3D printer. So basically, they've got a bed where printing is done, models to move the XYZ axis or the delta, and then there's a filament spool, there's a extruder, and then inside the extruder there's a hot end. So temperature at the hot end will depend very much on the kind of material that you are printing. And very common material is PLA, typically ranges from about 180 through to about 210. But if you have uh, you are lucky enough to have a carbon fiber printer, for instance, can go up to 240, 250 or higher, 300 degrees. Okay, next slide. Okay, so how does this kind of 3D printers work? Essentially, there's a feeder mechanism that pushes the filament through the hot end, and then this will extrude the material out under control of the computer inside the 3D printer. So this extrude the filament at the same time move the head to the correct position to lay the filament. Uh, so this now depending on model, sometimes the bed will lower as filament is printed. Okay, in other printers, the extruder head is actually raised as it goes layer by layer. Okay, next slide. Okay, now the 3D printing is actually considered as additive manufacturing. There are different kinds of manufacturing technology. Traditionally, you do things like the subtractive manufacturing, that's the CNC machining, and then there's injection molding technology. Okay, there's also the cutting technology. So one of the benefits of additive manufacturing is that you start with nothing and then you just add on material that you need. So in other words, there's minimal zero waste. You can also do designs, models that where everything is print in place, which is difficult to fabricate using other kinds of technology. But one of the main disadvantage is that it is pretty slow compared to other kinds of technology. But it is very suitable for prototyping. And if you listen to things like the moon, Mars mission, all that, one of the things that the industry is looking at is using local materials for 3D printing. Okay, next slide. Okay, so let's look at principles of 3D printing, the general workflow. Next slide. Okay, so you would start off with a 3D CAD model. This 3D CAD model can be a model that you design yourself using the CAD software, or it could be a model that you download from somewhere on the internet. Okay, there are many sites on the internet like GrabCAD, Yagi, Thingiverse is a very popular site. Most of the major 3D printer manufacturers will have their own sites, like Umagine for the LT maker. I think Prusa Printables, Bamboo Labs, which is a very popular model these days. They have the Maker World as well. So from the CAD model, you have to slice the model in order to send it to the 3D printer. So to get the file in the format that the slicer software can understand, very common format is STL, but that's a very old format. The more popular format these days is 3MF for many of the modern slices. Yeah, 3MF has got many advantages over the STL format. Okay, so the slicing software, again, that is pretty much dependent on printer manufacturer. So Cura is actually from Ultimaker, but it supports a lot of other third-party 3D printers as well. Prusa, Bamboo Studio, and Orca. Their slicer is based on an open source slicer called Slicer. Okay, so they share the same roots. So basically, if you if you learn one slicer, the settings are pretty much similar, and you can transfer it to other 3D printer models. The slicer will break the model up into layers, that instruct the head where to move and when to extrude the filament, control the temperature of the nozzle, as well as when to activate the cooling fan. So slicer software generate the G code for the 3D printer, and then you send the code to the 3D printer. Now, again, depending on printer models, sometimes you copy it onto a SD card or onto a USB drive. Many of the newer printers actually network, so you can send the file over to the printer across the network, and then you get the 3D object. Okay, next slide. Now, there are many terminologies, jargon associated with 3D printing. So I mentioned a couple of them, the file format. So I mentioned only STL, 3MF, but there are many, many other formats. So depending on the 3D printer. But those two are some of the most common these days. Okay, next thing we talk about is the resolution or layer height. So the height between 3D print layers, then the infill percentage. Okay, because normally when you 3D print object, quite often what we want is the outer shell, okay, of the model. So do you fill it as a solid or do you leave it hollow? Then there's also the wall thickness or shell thickness, the model that you're printing, whether there's any overhang from the vertical. That means tilted from the vertical, the concept of bridging, support structures if you have overhang, and then whether you need to have additional bed adhesion so that the model sticks well onto the bed. Okay, next slide. Okay, so let's look at some of these concepts. So layer height here, if you look at the model, on the rightmost model, the layer height is very large. So you can actually see all the striations in the 3D print model. Then going towards the left, the layer height becomes smaller and smaller until it's so fine that you can hardly see the layers anymore. Okay, one thing to know is that the finer the layer height, the smaller the layer height, the longer it takes to print. Right, next slide. Okay, so another thing to consider is when you have got a curved surface. Okay, so if you look at the model on the right, the diagram on the right, okay, here the layer height is the the step is very small, so it may not be that obvious. But as you move towards the left there, where it is more or less horizontal, okay, you can have the same layer height, but it becomes very apparent. Okay, so that's something that you have to consider in your 3D print as well. Okay, next slide. Okay, now effect of layer height. So here we've actually got one model that's printed at different resolutions or layer height. So you find that the finer the layer height, the longer it takes to print. Okay, some of the 3D printers actually, slicer software allows you to set variable layer height. So like the curve surface there, I could have a larger layer height for the more vertical and then a smaller layer height for the more horizontal layers so that the overall model still appears pretty smooth. Okay, next slide. Okay, next one is the shell thickness. So here it actually affects the strength of the model. Now, between the infill, putting in a lot of infill inside the model and increasing the shell or wall thickness, putting thicker wall actually gives you better strength in terms of compressing the model. Okay, and it's faster as compared to putting in the infill percentage. Okay, next slide. Okay, so that gives you the infill density or infill percentage. So you can go all the way from 0 to 100%, which is a solid block. But generally, nobody ever prints at 100%. For most prints, you find that somewhere between 10 to 20% is actually pretty good, unless it's something where you want to put in screws inside, then you need to have a bit more material on the inside, so you can put in a higher infill percentage. Okay, next slide. Yeah, so there's some notes about the infill percentage. Yeah, so some more information there. Now, when you say infill, there are many infill patterns that you can use as well. Most common is the grid or rectangular pattern, but there are many patterns that you can select, and which pattern depends very much on the purpose of your 3D print. So you've got some examples, triangular, the regal, and the honeycomb infill patterns. All right. Now, next one is the orientation of the model. So, orientation will affect how smooth the model looks like, how strong the model is, the quality of the surface finish, and whether you will need support structure or not. Okay, now, for instance, the filament is actually very strong in the left picture. So it's very strong in the uh, tension in the parallel to the filament. That means that I'm pulling there because I'm actually pulling along the filament is pretty strong. But when you're pulling across the layer from one layer to the other, the model tends to break because it's only held by the fusion of the different layers. Okay, so in other words, depending on what you're doing, you may have to orientate your model to get the strength that you need. Okay, next slide. Okay, so here we talk about the overhang angle. So if you're printing something vertical, no issue. You can print without support. Okay, for all 3D printers, up to 45 degree off the vertical, it is still fine. But depending on 3D printer models, once it goes past 45 degree, you may have to put in additional support. Okay, some of the printers, better printers, they can actually go up to about 65 degree without support still. Okay, so if you look at the letters, the T, Y, and H, okay, so something like the letter Y there, you can print without support because the overhang angle less than 45 degrees from the vertical. Now, something like the letter T, now if I orientate the T in this direction, then coming to the top of the T, you'll need to put in support because otherwise you're printing on air when it gets to the horizontal bar, so the layers will just fall down. Something like the letter H, what do you think? Do you need the support or not? Printing in that orientation. Okay, a large part of it will depend on how far apart the horizontal span is. That means the two vertical span, how wide is the horizontal span? So if it is close enough, you can actually print it without support. Okay, so next slide. Okay, so here we talk about the support structure. Now, when you need to print with support, okay, traditionally what we have is the normal support. So support all the way up from the build plate, the base, or depending on your selection, it could be support everywhere. That means even on existing 3D print material. Okay, but the modern slicers have a new kind of support structure, which is known as the tree support. So between doing the normal support and the tree support is a lot easier to remove. So if you really need to go for support, then put in tree support. Because there's yet another option. You can assign manual support. Okay, and you can also design your model. Okay, where you put in a sacrificial layer and do away with the support. Okay, so for instance, you're printing a cylinder with a hole in the center. Okay, and it's a plate that's in the air. So if you print without support, the whole thing will collapse. Okay, so you put a sacrificial layer. There's one layer. So after you print, the initial layer will be won't look very nice, but you punch through, you get a nice finish. Okay, but those are more advanced topics. So here, that's the concept called bridging. Okay, now I mentioned the letter H, right? Sometimes you may not need to print without support because if you've got two vertical structure, you can actually print a horizontal line, bridging the two vertical posts without a support. Reason for that is because if once you adjust the speed of the print head and the fan properly, you find that as the print head is extruding the material, okay, the fan is actually cooling it. And if it moves at the correct speed, it maintains tension. So you can actually lay the filament without support at all. So typically anything about 15 to 20 mm across, you can print without support. With proper calibration, you can print even wider, maybe 25, 30 mm. Okay. Next slide. Okay, so here, that's some educational resources that I've put in on 3D printing. So we are teachers. There's a site. If you click on it, there's a link to the site. So there are many projects there that you can use in your teaching. Yeah. So that's one example. Okay, now this is another example called Create Education. So again, many examples that you can use in your classroom. Fraction blocks, gears, topography map, and stuff like that. Okay, skeleton for bio teaching. Okay. So the slide on the picture on the left, that's a link to the source system. They've actually got a site where they say, okay, look, you want to get started 3D printing a classroom. So what are the things that you need? And then link to some additional resources from there. Right, and on the right are some additional links on 3D printing resources.
Thanks. We have added a few resources also in the website about AI for 3D modeling. Perhaps this is a topic that we can cover a little bit more detail in not next week, but in the open class 2 weeks time. Anyhow, you have the link of different tools that you can use for creating 2D or 3D models using AI. They are not very advanced, but perhaps, I don't know if Santi or Xavi, you want to cover something in the future. Anyhow, you have the links there and you can check it.